Just to make it much simpler, I love sailing. I followed my passion, and I got into trying to make my yacht go faster. So I did aeronautics, rocket science, went into aerospace. That was terribly boring. I ended up in automotive, and then in 2008, I started looking at buildings. And it was really interesting to discover that these drawings was still how we looked at buildings. And that's how I end up here today, with that background of being an engineer, yes, but aerodynamicist, really. BuroHappold, I spend my time between business advisory, digital startups, and creating companies, and BuroHappold. So BuroHappold is quite a cool company. They work worldwide. They're quite small, about 2,000 fee-earning professionals from Los Angeles to Hong Kong, but mostly started in the UK and the Middle East. We have 9 100-story buildings under construction in India as well, so we get to play around. We like to think of ourselves as one global community trying to solve the client problem. And typically the kind of problems we tackle are a difficult one, like an Olympic stadium, or a transport interchange like the Arctic there in a minute, or the City of Dreams. And why that puts us in an interesting position, and hopefully will give you an interesting story, is that to make that kind of buildings, you work for clients that actually want to challenge how things are done. They are ready to experiment, they are ready to innovate, and so we attract people that are ready to try to do a thing a different way. Because frankly, you're not going to manage to get that building out of the ground if you do it the same old. So I like to think about it as a digital landscape, and the story is in 2 parts. First is what do our workflow look like, and how we progressing. So that's the BIM story. And then, of course, well, what next? What's happening? Where's that? So let's just sort of remind ourselves of the BIM story. For the UK view, it's all about solving the deep problem of productivity that we have in the construction industry. That's why we ended up with a BIM mandate, and I think many other countries have different reasons why there has been BIM mandates, but all over the world we see this BIM adoption. And what does that look like? So BIM is, fundamentally a technology, and every technology goes through an adoption phase. And BIM is no different. So in 2008, when I joined this industry, you'd listen to the BIM evangelists, and they'll tell you that, world peace was within their reach. Of course, we had a GFC, but we also had to get through to reality. What it said on the brochure. Sorry, Autodesk, but we know. We are now getting into the plateau of productivity. So what does the plateau of productivity looks like? So, well, it was very interesting earlier on to see that IT spend in construction industry. Now, that's really interesting because that's a fact. But it's a consequence of what we in this room are able to deliver. Yes? People invest in technology because they get a return on their investment. So if we have a low investment in technology in our industry, it's because we collectively are not able to present or deliver or explicit returns. So the plateau of productivity for BIM adoption in BuroHappold is simple. The CFO wants me to give him 10% efficiency gain for a pot of money that I get to spend on technology, change, and people. It's that simple. So you break that down, process, policies, technology, people. These are the 4 areas that you're going to tackle, and you need to get 10% efficiency gain. And then you can actually try to structure that a little bit further, and that's what we did So we don't have a BIM team, by the way, at BuroHappold. I don't believe in BIM teams. Sorry, guys. I believe in a BIM company. Yeah, it's going to be the efficient business as usual. Yeah, so people say, you're the global head of BIM. Yeah, I tell them we needed to give a title for people to understand, but as far as I'm concerned, that's the same title as global head of email. Why? Because I am sure that in the mid-80s, when we rolled out email, there was a guy called global head of email. Do you want that job? I don't, right? So it's a change job, and yes, I have a team of 8 people worldwide that are driving change. They are driving change to making change in these 4 areas around these 13 tiles of change. And we Kanbanize the whole thing, and we just systematically driving change. That's what we do. But we are going to be a BIM company. Like, well, that doesn't make sense anyway. Because, you know, who is a PowerPoint company? Who is an Outlook company? Everybody is. So one of the real hard piece for engineering, okay, on this IOI is integration. So let me explain. When you sell BIM to an architect, it's great. I have 300 drawings to produce. I create a database and I report from it. As long as the cost I've invested in creating the database, I get it back because I can produce those drawings much quicker, fantastic, I'll invest in the database. Problem with engineers is that we don't have one database. BuroHappold is a multidisciplinary. We have structural, primary steel, secondary steel, concrete. Then we have fire, we have sustainability, we may have thermal gain models, we'll have HVAC models. We have many databases to construct. And anyway, its construction of this database is much more data intensive than an architect. An architect places a wall, we need to place a whole piping system. It's a lot more data intensive, and yet we produce many fewer drawings. So to get the ROI, you're gonna have to be able to produce the model much more efficiently. So how do you do that? Is integration. Think about it this way. An engineer has an analysis model already. It may be an Excel spreadsheet, or it may be a complex CFD simulation, but he has a model, and then he has the BIM, which, you know, Revit initially is just a drawing production machine. So you need to make them come together. As far as we're concerned, that's the first step. Get that to work, you will get your return. So how does that look like? Well, you have to think about, here is a stadium in the UK. You need to make sure that your geometry generation, analysis model, and BIM production model are all tied in and checked out. And it all checks out, and the only way you're going to check it out is by writing a bit of code. If you look at another stadium, yeah, we do quite a lot of stadium. What's really interesting is that this role of the technician and the engineer sort of starts to blur, because one's managing the data, the process, and the integration, and the other one is managing the design. But actually, it's one big giant piece of code talking to each other. That's what it starts looking at. And then, of course, that's automatic, right? That's kaboom. Once you've done the previous one, that's just kaboom. We've got a template, we've got a thing, poof, it comes out. The producing a drawing is a result of that investment. Now, you know, this is more MEP, so let's have a look at it more of an MEP. It's a lovely building in Los Angeles. This building is now out of the ground, so what I'm presenting here is what happened 3 to 4 years ago. It's a very elegant building, and like all elegant buildings, like pyramids, it's just a cut of a torus. So of course, a cut of a torus in Revit, that's horrible, but actually, to an engineer, it's just lovely. So you can see that what we try to think about is what's the data flow, and yes, if the documentation repository is Revit, we just need to feed Revit with all sorts of stuff. What was really interesting, of course, is that you need to go a long, long way towards resolving this kind of shapes. And, you know, first concept of resolution and how you can increase resolution when you're starting to create the database automatically is quite interesting. Another interesting thing here is this building is really easy to define and to say this is what I want to be built. It's a catenary equation. But if you want to draw it and say the contract is a drawing, you can't. Okay, it's only an approximation. And then if you say, well, I'm going to transmit you this information because that's contractual on paper, you end up having to transmit pieces of paper with hundreds of data points. Okay, that's the contract. Nobody can use the contract because it's a bad approximation. Yeah, if you send to the contractor that data sheet, that's contractual and is correct, but it's totally unusable. And yes, you get to a construction model, and we got all the way to a construction model, but what was really interesting is how that the data was starting to dance between ANSYS and IES, all into the same model, how we resolved all the BIM and created all the systems. They were all systems generated, all the electrical, all the loadings, everything was being calculated automatically, automagically. You could interrogate it. It was a truly integrated engineering and document production model, remembering that actually some of the documentation it was producing was useless, just complied to contract. This is another project where we're trying to start to think about how can we create single data entity for analysis that drives what's going to be delivered and constructed. We talk about the single analysis model. This is a project in Berlin, so a bit of German, but the idea is really simple, that actually you have an architect that's imposing to you some boundary condition. We then format that in something that is universal, push it into analysis, get analysis feedback, and then you start getting results back in Revit, ways of consuming it. That's really, really nice. And then, for example, stuff that you can start getting a bit more sexy and say, well, those schematics, how do I get them back out of the model? I know I had some line drawings, then I did some analysis, created my MEP systems, but I need to still provide some schematics because actually, let's not be negative. A nice schematic drawing conveys clearly a lot of information, but how do we keep these two things in place? So you can start writing a bit of code. It takes a bit of time to go through the video, but you can see where this is going. Is the schematic is linked to the model, change the model, the schematic change, kaboom, another one that we can put to bed and not have to worry about. And so you start going down that way, and this is where the team starts to get exciting. A few things going on the screen. I think the top right-hand one is the one that's really simple, and actually it's really nice. So here we are. We have a civils engineer that says, I was looking at the raft, and we need to support this building with piles that go into the rock by 2.5 meters, and the pitch is this much, but this is a rule of thumb rule, and it all aligns with the shear walls. It's really easy. So the guy said, well, why am I going to draw that? I'm just going to write a piece of script that draws it for me. So next time when the architect changes his mind on the shear wall position, just reruns the script, and it's regenerated the pile model. And you can do the same thing. So at the bottom there, that's putting a firefighting system into a stadium. Why not? Just put it in, run the script, the architect changed his mind, fine. We run the script, new firefighting system in it. The other one is the builder's work. Of course, most of the design at the moment is still really, design intent. Design intent because one, documentation is, limited of how much you can transmit. Second, because there's very little ability to optimize beyond the design intent. And thirdly, because we still like to design by Hilti. Take a big drill and, call the engineer, no, why? If you have a script like this one that just puts all the holes into the building, it's done, right? F4, it's done. So the architect changes his mind, we move the walls, the piles move, we recalculate the structure, the dimension moves, we relay out the firefighting, we press F5, we put the builder's work, we then press report, and we've got all the drawings. Okay? That is what I mean by let's get some productivity going. And of course, there are quite nice things that happen. You can sense you can go towards data resolution much further, so you can detect issues much earlier. You can also accelerate your design cycle, because typically we still live in a world of work in progress, issued, approved, and then shared, and that has a time cycle of 3 months. What's great is when you receive a script from your architect and you apply all your scripts to their scripts, and within 12 hours you say, there it is, with the builder's works. When do you want us to print the drawings? They say, don't bother, we just looked at it. So we're changing the design clock speed from months to minutes. So that means that code is starting to become important, because the code generates the BIM, so I'm going to need to archive the codes, so you don't have a document controller anymore. You're going to need to have a code controller, and you have to start having code architecture. Where is my sandbox? What am I testing? Where am my repository? So yeah, that's good. And then you have to go towards code innovation. So this was, software industries, they do hackathon. So this was one that we did with Flux. It's a company that's a Google spin-out. I think at Series C, they've taken about 50 million. They're doing some cool stuff with the cloud. So what did we do here? So we had, London and San Francisco live connected, and then we start, what can we do when we use the cloud, and starting to use cloud-based, permission-based transmission of information. There we can, some guys hacked a sensor, live sensors into the building, back into the BIM. Other guys were saying, what happens when we put our camera sensors that we're using in other part of the business back into the simulation model? We've got a live human that you can walk across the beam and see the beam deflect. It's just live. I don't know why you do it, but they'll find application. The other guy came up and said, I'm going to put it on top of a MongoDB, and it was very confusing. Actually, it turned out to be the more interesting one. So there you have the architectural input of the design of the bowl of the stadium. Then the structure drives the sizing. Then it calculates how the whole layout comes in. It then calculates visibility. Then it pushes it back into the model. And then you get a fitness criteria. How good is that stadium? What's visibility? What's cost, etc. But then because he's put it on top of a database, if you change something, it changes everywhere. That's the first thing. But the second thing is, as you change a boundary condition, you can rewind the model, because it's imaging every single version and every single change you do. So you have like a time machine. So it's just watching your BIMs, and you can reapply going forward every change you made to that design, but you've just changed the boundary condition that was 6 steps before. So it's starting to get quite interesting. This is another one. So because we're coding, we started partnering with some software guys, and created a little bit of a software. So what I like about content is that it goes very, very far. I was really interested earlier on. So what if your content was searchable? Yeah, so I'm placing content in the model, so I need Google for content. So this is Google for content. As you are in Revit, you just start typing pump, and it provides, or valve, and it provides you the information about valves that are in your model, but also in the library that you have inside your repository. And then, of course, it's really interesting because you can start managing the library. So actually, we index every single model that we've ever constructed and put them into libraries. And then we can check all the information against different data templates. So we can apply different data templates. So CIPSEs define the PDT. But of course, that works for performance specification or manufacturing specification on the same object. We can start reapplying different data. But we can also, from a BIM manager point of view, say, well, you know, is that model that I'm delivering, because I'm delivering data, does it match the data specification that I need to follow? Poof, yeah, it does, it calculates. And then you can start dashboarding it, you know, who's adding what at what rate. You can see, oh, somebody's done something wrong in the model, when was it added, who added it, and then you can start adding it to, you know, you push it into Azure Cloud, and then you put Azure BI on it, and then it starts answering, you know, who placed it, and what data do we have at that? And so the pump we put in the Arctic, who placed it, and what do we know about it? So it starts to get quite interesting, and you know, you start getting dashboard. That's the BIM model. So you ask me at any time, how many objects have you got in that BIM? I go onto the web interface, and I know. So the guys put together a small video. Somebody is to explain, you know, we call it computation engineering. And it tries to explain, you know, what we love and what we hate, yeah, which is just the drudge, the boring. So it's all about process, right? We want to be designers, we want great buildings. And those happen because we've provided a good environment, a BuroHappold, for great guys to come and work. And they're bright, and we give them, you know, difficult problems so that they can innovate and create money for our clients. And we do that how? By talking to our clients with sketches, etc. And then after that, it gets like, you know, 19th century, like with the ruler. It's called AutoCAD, but it's the 19th century version. So what's the 20th century version? Maybe the 21st century version of IP to innovation. And we think it looks, it's creating buildings through code. That building, we don't draw it, we program it. So the first version is not quite right, and then we introduce new boundary conditions, new structures inside, and it relaxes and it changes. Because we recompute, and then if we have another problem, we do multi-dimensional exploration, and then once we have something, maybe we need to produce a document, let the computer do that, just poof, populate, kaboom. We need, you know, we need to be able to attract interesting people to industry, to provide them an area where we say, yeah, the built asset is a cool place to come and work. Not just advertising with Google, yeah? Because the built asset's where we live. So, you know, that's quite deep, and, you know, architect friends are deep into that, but that's important. If we continue to deliver the built asset with 19th century technology, we will continue to live in a 19th century asset. I want to live in a 21st century asset, and so we're trying to do something about it. And that's, yeah, you can see it in action. That's coding and linking workflows, and it may look scary, but it ain't. It's actually really easy and great fun, and just like that feeling of relief when the pain goes away. And yeah, it looks different. You know, you have your Dynamo scripts, and you have to share knowledge, and then we have to create communities. So this is a community that we have people talking about MEP, computational. Here we had 53 guys. You know, this is not a BIM group, or this is not a computational group. This is a global community of 1,800 engineers getting busy with technology to solve the first problem, which was get the workflow to be efficient. That's computational engineering. That's part one. Because obviously that's just BIM 1.0. This is efficient BIM. Okay? But we live in a digital landscape, right? Let's look at the broader construction industry. When I say, you know, I don't want to live in a 19th century environment, I was not joking. These are real data. The one on the right, many people see many different versions. I think we've touched upon it many times already in the last 2 days around the fact that we need to eliminate waste in the inactive, unproductive activities that we do. Yeah, we are like 2 or 3 order of magnitudes behind the rest of the other industries. And then when you look at project delivery, it's horrible. I mean, look at the global scorecard. If I said to you 71% of computers cost more than what was on the ticket, 86% of airplanes don't land safely, 45% of projects, 45% of hospital procedures last, 6 months or more. I mean, it's horrible. So we need to think about it. We need to challenge ourselves. And, we have to remember, I'm not insane. I don't want to just do same old. So the first part's BIM 1.0. Let's call the rest BIM 2.0. Follow the software industry. So if you are interested in these, digital transformation structure and frameworks that can allow to drive strategy, this is a good one. But essentially, it says if you stay in the adopt box, you end up dying. Okay, so to survive, you have to leverage the technology. You need to remain competitive. Okay, and the excite box is where a lot of people start. They discover that I can do something new, and that's where it comes from, right? But let's not forget, okay, that the excite box is a dangerous box to be. Everybody remembers Rio. Rio had 95% market share of the MP3 player. Yeah. They were in the excite box. You die happy, but you die. So you need to find things that you can transform, and you have to think, okay, well, yeah, you've all seen these things, in 1 second, or all this world of data, leveraging Moore's law, yeah, and then, this is just providing a framework that says, smack, it's like, smack your child, social, mobile, analytics, cloud. Think about these things and apply them to what you're doing. And then you can see people, you have use cases around, data system, industrial machine, IoT for us, the conscious building. You can put all these things onto our industry and think, interesting, what dots does it join, and where can I start changing, where can I start doing things better? So a couple of ideas. How do I create value through increased data resolution? Because you saw, I'm becoming much more efficient at managing data. And let's remember, think about what a design office looked like in 1982, what a design office looks like today. Has it changed that much? I don't think so. Not really. So the first thing I'm telling you, stop talking about BIM. Just get rid of the word. It comes with so much baggage. It's a technology. Okay? It's like somebody talking about the internet, and he's talking about IPv6 and IPv4, and he comes into the room and he says, I've got a great thing that's going to change the world. It's going to change the way we communicate. And so, you have the IEEE definition for the RJ11 interface, and then it goes into DNS servers that do conversion between the DNS address and the URLs. And then, but anyway, I cut it short. We've got a really cool thing that has HTML tags, and it's HTML5, and it's links, and it's, what is it? It's called Facebook, but I mean, it's really good. And it says, explain to your grandma what Facebook is, look, you join and you can see the kids, right? You don't talk to them about IPv6. So when we walk in and go and see the CEO, we shouldn't be talking about Kobe and Revit 2017 release pack 3. Please, let's talk about things that they understand. Money, or in this case, we start saying, well, we've got data. Let's start using it. So this is the kind of stuff we're starting to do. Just a random walk in example. If you have 2 towers, You know, they're going to interfere, they're going to create wind, they're going to create wind load, they're going to create noise, they're going to create insulation. So what shape should they be anyway? So you can let the computer explore the whole design space and say, well, if you like more a triangular one, that's the one you should pick, etc. You need to connect your applications. Data is pervasive through the whole business. All business is design, so data becomes... And then, you know, go and seek data. So we design stadium. We want to know which stadium are good. Define a good stadium. Well, if you're the football club chairman, it's a stadium that makes you win more often. So it's a stadium that has more home advantage, which he translates in the fans are happy and cheer my team. Therefore, we better know which stadium allow the crowd to cheer for their team best, right? So you go and measure the crowd, and yes, we are designing Atlanta Falcons Mercedes Arena, and it's designed to give the Falcons a home advantage, because that's what they want. We didn't talk to them about Kobe too much. You know, it's scary, you know. To know the performance of a building, you need to know what's happening in the building. You need to normalize it. You know, if you say, hey, at the moment, the energy consumption and the energy footprint is really low, yeah, if there's nobody in the building, we're good. Yeah, you need to start using how does the asset get used, so you get that data. You need to get interested in how the building is actually performing. In the UK, there's a big drive on post-occupancy evaluation. I think it's worldwide. Ultimately, you know, it's like a car maker that designs something and then build it with his build team and then go. There it is. No test track. It's just gonna be great. It's just, you know, it's running in the workshop. Just push it out. Well, I mean, I'm a believer in simulation, right? But ultimately, the ultimate test for reality is when real world, what you call reality and your perceiving, doesn't match your simulation. If it's matching your simulation, you're living in the matrix, okay? It's that simple. It's the ultimate test. So go and measure, get data, close the loop, get it back into your design, but first help the guy perform, okay? And it matters, you know, but again, talk CEO guy, you know, CEO, lumens, yeah, but actually, productivity increase with lighting by how much? Let's get the data, and then let's drive so that you can optimize. Should I put more power into this building? Well, if I put more power, more heat needs to come out, the energetic footprint gets worse. Yeah, no lighting. Yeah, it's like, well, a dark building will do. No, obviously you need a bit of light. Well, how much? That's how much. Same with heating. You know, how much does it cost to overcool, overheat? And what's the impact on the occupants? Let's do the same with air quality. As CO2 content increases, guys stop sleeping. You know, if it's an office building or a retail space, that matters. They don't buy, they don't work. Noise, yeah, and so you start getting performance index and you breathe it all back into the design. And really, this random work is just to say, you know, ultimately the architect will tell you forms follows function or function drives form, you know. No, it follows data. Yeah, the ultimate arbiter is data. So we are in a data world, which then brings another question, you know, data mobility. We talked about data density, data mobility. So why is it so hard, and where does it create value? Now, this is a great slide. It's going to take a bit of time to explain. But at its heart, what it's trying to say is that we have it much harder. We shouldn't hit ourselves for not using IT so much. Because if you're going to create value through data mobility, then that data mobility network, that data network matters. What does it look like? Well, a child of 5 can tell you that the one in the middle is very different from all the other ones. Okay? So that is the difference between an automotive and a construction firm. It's there. In financial services, data is highly concentrated, doesn't bridge corporate boundaries, a few plugins and you're good. Look at construction. You have so many entry points. You have so many ways of connecting, so many different points to connect. You're a global operator, but suddenly you have all your local supply chain. We know that. That's what that graph shows. Now, there are 2 ways to deal with that. The first one is to create a company that looks like a financial service or a manufacturing company. Yeah, you industrialize by becoming like an industrialist. That's option 1. Yeah, data mobility creates value through PLM, standard PLM in manufacturing. Let's go PLM and create companies that looks like manufacturing. That's option 1. And it took about 25 years for the automotive companies to restructure their whole supply chain at corporate level, sell, buy, merge, to get to that picture, and it worked. But they have, they are not local. Yeah, I can make a Range Rover in UK, put it on the ship, and send it across the planet. I can't do the same with a building. It's not the same thing. So option 2, we're going to have to data mobility work in construction with that map. But now that we know we have that map, yeah, we know we can sort of address it. I'm pleased to see the guy from Squiz that, in the front. These are the guys that are actually thinking, the 21st century. We say, that's the construction map. When we have a broad social network that we're trying to connect, let's create an ecosystem that allows companies to connect their ERP. Create a platform that connects ERPs, vendors, specifiers, and then we can start changing information. How cool would it be if when I'm looking for a valve, I could just say, well, this building is for Australia. Actually, I'm not going to say that because my AI already knows from the Revit 00 that it's in Australia. So. And it's saying, the Australian supplier that can supply this valve, here is its catalog. Do you want to import it? Of course, that's how the rest of the world thinks. Let's start thinking like them. Let's make it, very a little bit more specific, so that you don't think I'm just theorizing. So one of the interesting things, of course, is to look at the very simple view of this project space in terms of data. We have 3 buckets, right? Design, construct, operate, neatly divided with large contracts and handovers. And I'll sue you across those boundaries. At the data view, we're losing data. That's the tragedy. What does happen if we can bring that full data space together? How can we get the project space to talk to each other, right? Because we're really interesting. We can start feeding the design information with what architects call precedent data. We just call them database, archive, okay? So if I design a yacht for the next round the world race, I just get all the weather data for the last 20 years in the months that is going to be run. Same for the Sydney Hobart. And then I get every single winner, and then I analyze, and I can start getting information. Then I build the boat, and based on the construction logic, I feed it back into the design logic. So construction logic feeds design logic. Then I operate it, and I find out that actually that was a simulation. Reality is different. I'm not in the matrix. I go back, I race, I get the precedent data. What were the actual loads? What was the actual speed? I start measuring other stuff, like, hey, the boat is really, really fantastically fast, but the guy on board can't sleep. Bit of a problem, because then his performance drops off. I've gone too far in optimizing a boat that goes fast, forgot the passenger. Okay, go back. Yeah. And it's really interesting. We are now designing yachts for their management system. Okay, so the way an automatic pilot is able to steer a yacht is very different from the way an owner or a helmsman steers a yacht. It stands to reason. I can look over and I can see the wave. And I can see the wind. I anticipate. That's a big one. I luff up, right? The automatic pilot can't do that. So the two yachts are going to be fundamentally different because the operate phase is informing the design and the build, okay? And performance can be transformational. We saw it at the F-15 to F-16 phase, okay? The F-15 is an asset, it flies, but it's an asset that's designed to be fundamentally stable. So you switch it on, you are at stable flight, it hits a cloud, it still continues flying flat. It's aerodynamically stable. Don't design an asset that is not stable. So if you have a feedback loop in your BMS, that somebody walks into the room and then suddenly it picks up, oh, the room's heating up, and it keeps on adding cold, suddenly you're freezing the whole thing. You need to be able to get a feedback loop in the system and construct it. Now, the F-16, actually, the whole plane is designed to be unstable. Why? Because if it's unstable, it wants to turn. And if it wants to turn, by definition, it's more agile. The only problem is when you don't want it to turn, let's make sure that it goes straight. So you put in place a system that's quite unlike any other, which is to keep the plane going straight when you're giving no input, and when you give an input, execute. But it's going to be much faster. That's automatic stability control. You have it in every German car today. Where are we in the construction industry? Well, we're talking about it. Here is another one. This one's quite cool, you're going to see. So how do you design one of these buildings? So we're privileged at BuroHappold because we have clients that come up with these kind of things. I mean, it's beautiful. I mean, it's 0.001% of the built asset. So we have absolutely no credit for actually attempting to solve it another way. But that gives us the responsibility to share so that people can learn what we've learned. So this building, to design this building, you're not going to go about it in a conventional way, and you're going to need to think deeply, how am I going to make it? So in fact, you're going to design for construction, for erection. What is shape halfway built? What does the mill look like? What is the manufacturing process? So, when I hear, MEP subcontractor and other head contractor talking about manufacturing industrialization, I'm saying it matters to us because we need to get that conversation going. Look what happens. So this is a typical design process. You get Rhino models, scripts. You start getting analysis going. You then start rationalizing, and then you get into all sorts of complex shapes. There's not a straight line in this building. And then you get into connection design, and then you have to resolve it all the way. I mean, how could you print a drawing? How could you send a file or transmit the construction information if you didn't know what's the machine that's going to actually make it? You have to, otherwise it's not going to be made. And it is being made. So we did succeed to bring together the construction space and the design space. And yeah, sometimes the designer feel a bit design indentation, my feed stops there. But actually there's so much value that those are going to start talking, are going to really make a difference. And it's a real building. So what if we reverse the problem and said, I know I can do crazy building. What about simple building? You have all this scripting, this knowledge, this inventiveness. What if we could just use all that thought onto a simple business? There's nothing simpler than a box. So what's going on here is, he's adding floors. So we're creating a typical, car configurator. You just draw the footprint, how many story, what's the facades looking like, and yeah, the car configurator, the way you're configuring your Mini, this one is configuring a building. So now we're going to add the MEP, so obviously we have to do the same with the MEP. And by the way, AI routing of MEP, if its exploration is complex, we're starting to see AI solutions, but today we don't even need that. It's just simple rule, you know, the sprinkler on, you know, ceiling centers, and they need to follow some code. You code the code, and kaboom, yeah, the building becomes automatic, and then you have your boundary condition, and then you add some more code to increase the resolution, and there it is, and you can see it appearing in Revit, full coordinated. So obviously, for example, one of the cool things about that is I hate talking about clash detection. Okay, we don't do clash detection. Why would you? Why build it and design it wrong in the first place? Clash avoidance, yeah, but clash detection, no. Okay, yeah, but this kind of thinking is like, yeah, I know I keep on talking about the car industry, but the car industry 20 years ago used to spend 5% of turnover on rectification. They built it wrong, and at the end of the line, they had the QA team that rectified, okay? And somebody really clever said, what if we spend 1% getting everybody else building it right first time? I mean, you know, why not? Then we can save ourselves. Remember, the car industry in a good mid-cycle year does 10%. So half of the profits are gone because you're building the car wrong. So change the way you build the car, and you don't need to do clash detection. So all this effort at clash detection, please now clash avoidance. Yeah, you know, if you put the pipe and it refuses to land there because it knows that there is something there already, that you're going through a wall that we aren't gonna be able to pierce, don't let the pipe go there. You know, why not? So there we go, that's the automatic building. What's cool about the automatic building, if you think about it, is buildings are actually all the same. You know, they're like on a structural grid, 8 meter, 9 meter. If you're in an airport, it's 12 meter. They're all pretty similar. There's lots of, a bit of difference, okay? The envelope, the boundary condition, the country, they're boundary condition. But 90% of the stuff that's going in is standard. You know, if you said, design the lighting system into this room, you know it's a meeting room, therefore it's an auditorium, it needs those type of lights, just populate, you know. It's standard, or it's nearly standard. Just back to the point earlier on about a hospital, not two sections of 20 meters were the same, but they were a slight variation of each. Let the computer configure, because it can be automated. And yeah, there we go. So that's the automatic building. So that's pretty cool, because then soon your design is an app, right? Just provide the boundary condition. So, but my message here is we're going to create a lot of value through either closing the loop or thinking slightly differently. You know, the architect, which on the emotion and the context, tends to dictate to the engineer that, you know, he tries to respect the laws of physics. You know, how often does that happen? And we're seen as the people that make the building function and make the building useful. And then your QS is going to try to optimize that for make it fit the budget. Sometimes there is an iteration, you know, does it fit how can we make it fit the budget? But it's always like construction is a subsidiary of design. It's not the real world. It's not the real world. The real world should be like this, where we have a conversation, where we start putting dependencies. We bring the build logic into the design. We bring the operate logic into the design. The design logic goes back into the BMS, because you need the physics laws to program your BMS to operate. You can't program the F-16 stability control if you don't have the physics model that represent that aircraft. You can't. You need to start the conversation. So I'll leave you with this, with this thought, which is not new, which is Mark Andreessen, you may know, may not know, is a venture capitalist. He started Netscape, he started a few companies, wrote an essay in the Wall Street Journal in 2011 saying, you know, if you think about it, everything is being driven by software. Financial institutions are software companies that are operating in the financial world. This is what's going to be happening to us. We need to become and start thinking more like software companies, because software drives efficiencies. Now you can choose to ignore that, and then you will be disrupted. The advertising agency chose not to think as software. They're now dependent of a software company. My choice is to work with the industry to make sure the industry retains all its knowledge, and we actually run the world, not the software geeks. And on that, I'll take questions or...